Welcome to this episode of the Structural Engineering Channel, a podcast focused on helping structural engineering professionals stay up to date on technical trends in the field and to help them succeed in their careers and lives. In this episode, we are talking to Michael Bolduc, a registered professional engineer in Massachusetts and the senior project manager at Simpson Gumpertz Heger, about automation and communication in structural engineering and how engineers can help avoid the increasing pressure on structural designers to respond to major architectural changes or coordination issues late in the design process. I'm your co-host, Kara Green. Now let's jump into our conversation of the week with Michael.
This episode of the Structural Engineering Channel is brought to you by PPI, a leader in engineering exam prep for the PE structural exam. PPI provides expert prep courses and study resources designed to help you pass the PE structural exam the first time. PPI's PE structural course is fully updated and taught with October 2021 code references and includes new editions of their PE structural books. PPI's live online courses include hours of lectures, problem-solving demonstrations, exam strategy sessions, office hours, and a passing guarantee. When you take a live online course, PPI guarantees you will pass, or you can take the on-demand course for free. PPI has helped engineers achieve their licensing goals since 1975. Check out PPI today at PPI2pass.com to see all of the resources available for PE structural exam prep. Again, that's PPI2pass.com.
First, Michael, welcome to the show. It's such a pleasure to have you. Could you tell us in your own words what you do on a day-to-day basis?
I'm a senior project manager with Simpson Gumpertz Heger. I've been working with them for a little over 20 years now on a variety of projects. I've done everything from healthcare to lab science buildings to parking garages and a lot of retrofit and repair work as well. So kind of a wide variety of projects, wide scale. I run a small team now. And in general, just kind of take any type of structural engineering task that needs to be done from new design through repair and rehab of projects.
That's awesome. And so you've done like the wide breadth. I'm familiar with Simpson Gumpertz Heger. I worked with them a little bit when I was in Houston.
Oh, gotcha.
I know.
Okay. Small world.
Yes. Well, the engineering world, I feel like, is very small. Now, Michael, you actually co-authored an article in the March 2021 Structure magazine called "Communicating in a BIM World." Can you explain a bit why effective communication between architects and engineers is so important and how it affects the success of a project?
Sure. That article is done through the SEI, Structural Engineering Institute, digital design committee. We put that together as a means of trying to get some word out that we've been having conversations about and discussions we've been having. The big thing we really find with communication is it's even more critical nowadays than it was when I first started my career 20 years ago. It seemed to be a little more natural back then. The pace of everything 20 years ago was much slower, and the pace over the past years has just accelerated so quickly that making sure you're clear in your communication and that you are communicating are two of the biggest things we have found struggles with. One of the other challenges we find is that the ways of communicating have become so numerous that you're inundated with multiple types of communication, whether it's texting, IM, phone calls, chatting with clients, chatting internally, emails. There's so many different ways to get in touch with people. It's important to kind of set the boundaries on how you want to communicate on a given project and make sure that you are not missing information. Sometimes people will post comments in some of the new modern technologies with BIM 360 and other things that allow you to have comments that if you're not tracking them, you can miss those comments. That's that communication piece you really talk about, is how are you going to be communicating on a project? So you need to actually communicate how you want to communicate, I think, is one of the key takeaways in the modern ways, multiple ways of talking to everybody.
Yeah, that's actually a great point. In our company internally, we talk about a lot on like what is the best way to communicate, and it's kind of interesting because we have a peer council that discusses it, and it's like, everyone communicates differently, but you have to consolidate it somewhere. It's so important because you do miss things. And Another thing that I wanted to touch on, so, you mentioned communication in different teams working, especially now, I feel like architects, builders, engineers are all working extremely closely together. Do you see like the BIM, does it work? Do you see it working more in just like an architect to engineer space, or do you see it in an architect to engineer to builder space, or, do you see it working better with a certain group?
I think it works in all groups. Like, it really comes down to just setting those boundaries and setting those communication standards up early. Because I think what really can happen is when you're talking through a project and you start communicating about it, whether it's with the builder during CA or during the architect during design, oftentimes I feel like what happens with a model is people are just going to say, well, here's the information or here are some comments. And there's no context. And so one of the things you always have to ask for is, I often find myself asking for the context. Why are you asking this? What are you trying to achieve? Don't just throw something at me. And so oftentimes if I get a question, I'll immediately follow up and have a conversation, because a conversation places the context of what you're trying to achieve, whether you're trying to answer a question on during design, or you're trying to understand why somebody did something during design, or if an RFI or something comes in during construction. What are you trying to achieve? Are you trying to do something differently? Are you just finding things that aren't meshing up the way you thought they were? It really comes down to putting everything in context, I think, is really the key thing. And I think one of the things that kind of seems to be getting lost in our current ways of communicating, we just get inundated. So it's a quick answer every time. And sometimes I've had conversations or emails back and forth or any sort of communication method, but you go back and forth, like, are we even talking about the same thing anymore? And you kind of get off track with each other. And so sometimes it's pausing, picking up the phone, and just making sure you actually talk to somebody and understand what they're looking for to make sure you're actually giving them the answer that they want.
Yeah, I think that's a great point. Context to a conversation obviously completely changes it, or it can, really strain certain things and make it difficult
Mhm.
if you move forward. Um, so in the article, you said, and I quote you, the development of sophisticated and truly integrated design tools has been limited to high-profile design projects, whereas the more widely adopted tools have not lived up to the hype per se.
Mhm.
Can you explain to us what you mean by that?
Yeah, I think it really comes down to the true integration, and I'll call it full modeling, like I'll call it full virtual building type model, really only happens. I'm only seeing it on, and I haven't seen it personally, I'll be honest. I'm seeing it on large scale projects, stadiums and airports, really massive projects where you have the time and budget and they dedicate it to the design team to say, we're going to put the effort into getting this thing to a construction ready model during design. So you can basically spend the time and effort and budgets early. Um, but that only seems to happen on these what I call mega projects, right? You have the time and effort to put into it, both from a software perspective and the specific software that's been developed for those particular types of projects. I think the real challenge is the everyday type of project. The budgets are often so tight, and you have so many critical elements that are you're trying to squeeze in such a short window of time and short window of budget that you don't have the time to spend and get the model maybe as fully developed as to get a called digital twin kind of thing. Digital twin being a virtual version of a building before it gets built. Um, the time and budgets in typical construction projects just don't have that allowance for you. And that's what I have found. And then in talking to others that have worked on some of these large stadia, they say, no, we have a little more time, but the time may be crunched, but the budget is there to put people after it, add software. And really what's happened on those is you develop software or you spend time leveraging the software that we have to put all the details into it. So I think the challenge is really time, right? We don't have the time or budget to do everything we'd love to do. I would love to build a building down to the nuts and welds and everything. The budgets don't allow it, and no developer or contractor wants to pay for it. But if you do that, I find on these bigger projects, you can really coordinate everything down to every single duct penetration, every single run of mechanical, every architectural feature. How does it all fit with the structure? And you get all of those components coming together. If you spend the time and money early, it can be done. It's just the industry, I feel, doesn't allow the design team to bring it to that level because of the pressure to keep costs down.
Do you, and this is just something I'm curious about because, keeping costs down is very important, especially to a lot of owners, especially to a lot of owners who maybe do more smaller projects and they are more constrained. Um, Do you see maybe the design team or the construction team, due to these also time requirements? I feel like time is a huge issue right now. Do you see them maybe pushing for a more modeled system beforehand to prevent the time requirements? Because, time also is a heavy influencer on budget.
I think it's where do you spend the time? Do you spend the time early or do you spend the time in construction? That's what I have found over the years, is that it becomes more of a, if you have the time during design, then you can do a lot. If you given the time, we can get a very accurate, coordinated, and really tight design together. The problem is the design, even the design flow for the past, over my career, I've seen it really change from true milestones where you put pencils down, you stopped, you coordinated and moved on. And then when you hit a milestone, it was done. You kind of said, we're done changing this. And now there's so many steps of design that I really think that the continuation of design follows right in construction. It's really almost design build in the sense of you're designing as you build it, because things are constantly changing, because everybody comes in with a new idea or an owner changes. And so I think the challenge we have is, where do you spend the time? Is somebody willing to put the time in during design and say, we're willing to give up a little more design time and spend the time to get it accurate, and then hopefully have a smoother construction period? What I have found over the past decade or so is that everybody pushes to get in the ground sooner and sooner. Early structural package, or breaking your structural package into foundation, early structural steel, sometimes way before the architecture is even complete. And you're trying to put up a frame and then scab on what I call the jewelry to the building, all the ancillary supports for the window frames and everything else. So you start building it into these packages. And so the changes become much more challenging down the road. And so you don't have that time to coordinate and really think through as a full team, is this the right approach? It's more of a reactionary design rather than a proactive design.
Yeah, and I'm familiar with reactionary design, and a lot of times there's a lot of rework that happens. And this is kind of, you have a tenure in working on projects, and you've worked on, it sounds like, both mega projects and retrofits, so all sorts of sizes. Do you have any strategies that maybe structural engineers, maybe some of our younger audiences, or someone who's getting into a more dynamic design flow, what they can adopt to help them minimize the rework penalty and stay efficient during the design process, and also to prepare a future where maybe a BIM option, even on maybe a mid-size, not just the mega projects, mid-size projects could be a deliverable?
I do think the goal long term for our industry is BIM as a deliverable. And what I'm seeing more and more is the BIM is becoming a communication tool. So when you send a model across, even if you send drawings with it, the model has started to become the thing that everybody looks at more so than your drawings. And so it's important in that sense to offer placeholders. So I talk about communicating in the model space. If you know you have a detail, say for a kicker along a facade, but you don't want to model the hundreds of kickers around the outside of the building because it's tedious, time consuming, and it doesn't really add too much to the drawing set. The drawing set communicates it already. It's important to communicate that within the model. So what I'm finding is trying to find ways to communicate within a model to either point somebody to it or say, hey, this is a zone you want to take a closer look at. Make sure you're looking at details in this area. So I think part of it is placeholders within your model. And the other challenge with models is that models, if you put a bunch of detail into a model and then have to change it, it's even more work to change that detail. So I struggle with oftentimes my young staff or training our young engineers that you have to only put in what's necessary at a given time point. So if you detail too soon in a model, then you end up, and a change happens. Sometimes it's nice in a live model or a live section. Yeah, it works, great, but it doesn't change everything, right? The documentation and the model aren't quite perfect yet, or you find yourself having to change things for a multitude of elements within a model. So I have found that you try to model just what's necessary at a given time frame for the project. And unfortunately, what it means for us as structural engineers is a lot of that work gets pushed to the tail end. So it's this crescendo of work towards the end of the project, and this real push at the end to try to add all those detail elements you have, but you didn't want to put in because things were potentially changing. That's where back to communications, really trying to find out what is on the chop, what is a potential change, and what is really locked in. So can we do, say, the east facade? Okay, can we do the detailing in the east facade? Is that really locked down? Is it ready to go? Yes or no? You know what, we're thinking about doing balconies or these other canopies that we're looking at doing. okay, I'm going to hold off on doing that area. I'm going to push that off and wait and try to find some other areas that I know are more locked in. So it's really important and critical for the young engineers to identify what, at a given stage in the design, what is actually locked in, what is done, and what can we say is locked down. And then contractually, you have the chance at that point to say, hey, I'm going to lock this down. Tell me if any changes come from here, I'm going to ask you for an ad service to change it because you told me it's locked. Are you agreeing to that? That question will oftentimes go, well, wait, maybe I'm not quite as locked in as I thought I was. And so oftentimes you put some money or something else on the table just to say, hey, I'm going to lose my shirt if I have to keep changing this. I need to know that we can lock this down. And that's where the difference from early in my career, I found that lockdown happened a lot sooner. And the design was kind of fixed, and you then detailed that design. So I used to say lockdown happened at DD. The plans didn't change much after that. You added some notes to it, but it didn't really change fundamentally. Now I'm seeing those changes come during CDs and how many projects. When's the last project you issued without an addendum or without a bulletin? I don't think it happens anymore. So construction documents are just a check mark in time, and then they continue design changes. Whether those design changes come from the architect, the owner, or the contractor, all three tend to have some influence as far as those changes coming in later on. And we as structural engineers tend to be more reactionary to those at that point in time.
Yeah, and I think it's funny that you bring that up because I used to be like a junior engineer, and all of the edits I had to do them because I was also the cheapest on the project.
There you go. Exactly.
And it would always be really funny because the owner would come to me and I would do like a preliminary design, and he'd be like, it would be like a month later or so, and I'd come back and he was like, we need to edit these. And I was like, but I thought we were good with the first set. And he was like, no, there's been some change.
Yeah, I had a couple meetings and they changed a bunch of stuff. You're like, okay, nothing wrong you did, but it was just changes that come down the road. And that's what I tell the young staff is that there's going to be changes. I think the biggest thing now is anticipate change. Just expect it. It's going to come. So don't bring things to what you think is a final state. Bring them to where you know you're close, and leave yourself a few notes or put some notes on there and say, hey, you need to come back and fix these 3 things once it's locked in and you know what you got to do. So it's almost leave yourself breadcrumbs along the way, kind of come back and say, these are things I know I need to finish up, but I'm not going to spend the time now because I think it has potential to change. But then the problem is you kind of set yourself up for a big push at the end, and then you're pulling late nights and trying to really have that deadline mentality that kicks in. We've all had it. We've all been there, whether it's in
we
school.
Have all been there.
It's like midterms all over again, right? So.
Yes. I know working and I used to work in Alabama, and there would always be like the last week of the month, and you had to get everything into like the plan committees and everything, or the permitting committees at the very beginning of like the next month to get them moving
to get
forward
on their schedule and their meetings.
Yes, and I would sit there with my supervisor and we would plan it. I won't age myself, but that's when we would print on a plotter. And
I remember paper. I remember hand marking paper. I'm with you.
Yeah, it was definitely a rush then. I feel like it's even more of a rush now.
The pressure to consolidate the time. I think that's just it. You're trying to do so much in such little time now. That's really the challenge that we're facing.
Yeah.
And that's, as an industry, it's really what we are. That's the biggest challenge I find for young staff. And one thing that I find that young staff coming in, that they are a little more adept at bouncing from task to task. They just come in as multitaskers, like coming out of school. In the past, they've grown up in this internet wired world where everything is just happening and changing so quickly. So young staff, I find, adapts to that a little bit better, to that sort of crazy mentality of constant change. But you have to prep them to say, hey, you think this is going to be done. It's not handing your paper to your professor and it's over at this point. It's going to get handed back to you and you can rework it again, because that's typically the process that's going to happen.
Yeah, that's what I wish my professor had done.
Exactly. Give me a chance to get it right.
So in another article that you published, I guess this March of this year with Structure Magazine, it was called Automation and the Future of Structural Engineering. So you talked about how tech allows us to automate responses. And I think, we were just talking about younger engineers because I have a couple of junior engineers who work at Hilti with me, and they're actually really good at this. Can you talk about like what you mean by automation for engineering, like in the professional engineering world?
Yeah, I think the big thing for automation for us right now is trying to automate what I call the low-lying fruit. Take those mundane tasks that we find ourselves having to do, whether it's checking beam sizes against a model, checking the span to depth ratios, all sorts of rules of thumb that we used to have whether it's in wood, concrete, steel. There's a lot of rules of thumb that have been used over time, and they've stood the test of time. They still apply, and say, is this a good design? Like, is this a rational design that's here? And so you can kind of use, sometimes I think what happens is you get feedback from an analytical software and you say, okay, good, that's it, I'm done. And you trust the software implicitly, which is fine. But there are ways to say, hey, is there a more efficient way to do it? Am I pushing the limits on serviceability, which sometimes doesn't get checked as much? And so I find that what I'm pushing my young staff for is repetitive tasks. You find yourself doing something on a repeated basis, whether it's a simple, I'll call it document management thing, where adding revision clouds or revising things over and over again, or just even changing title blocks. The things that you find yourself doing repetitively, if you've had to click 3 or 4 times, you're doing it multiple times in a given document set, try to find a way through the various Dynamo scripts and other scripting tools that are out there to automate it. So I think that's really where we've started in our firm, and other firms that I've talked to in the SEI Digital Design Committee. We all talk about how can we sort of get the low-lying fruit? Where is the pieces that we find ourselves doing repetitive work on, and where can we streamline that process? And what we find, I equate it to sort of doing like a beam check previously, WO squared over 8 on a simple beam, right? You used to run a quick hand check on it and check it. We don't need to do that anymore because we trust the software. You check the input, check your boundary conditions, everything else, and know that the software is working correctly, but you don't have to do the analytical piece of it quite as much. But in a model, you can actually get some of that feedback of, hey, even though the analytical software tells me I can have a W14 supporting a W24 beam because it works for strength and everything else, it doesn't make sense connection-wise and other things that might not be caught in the analytical software. So those are the kinds of things that you can check. Beam framing to each other, span to depth ratios, thicknesses of slabs, footing sizes, those sorts of things that are low-lying fruit that you find yourself, anything you do repetitively, that's really where you want to try to find a way to automate those tasks, because you're going to have to do them over and over again. And if you can find a way to make it faster, it allows you more time to do the other types of changes and other things you have to do.
Yeah, the more impactful changes. I feel like the ones that are automated are almost like a simple thought process, but the ones like where you can make a lot of change are the ones maybe that require a bit more thought. Exactly what you said, that the software doesn't necessarily catch.
And the goal is, sometimes I call it keeping engineers engineering, right? So keep engineers doing the things that are actually thoughtful, that if you can find a way to let the software do some of the more mundane thinking, let the software do those simple repetitive tasks and allow you to think through, what are you really showing? Is the right, I always explain to the engineers as well, the hardest thing to find in a set of drawings is what's missing. You can always critique what's there, but the hardest thing to find in a drawing is what's missing. So trying to spend the time looking for what's not there rather than just looking at what's there and trying to correct it. I'd rather have my engineers spending that time and let the automation and corrections happen through visualization. And those visualizations can be done through the model. You can leverage everything that's in the model now to sort of get you some of that feedback, whether it's a red, yellow, green check, flagging things that don't meet certain criteria. That's the benefit of the model now, is you have all this information at your fingertips. It's tapping into the I in the information, building an information model, tap into that information piece, and you can get a lot of information back and feedback in a multitude of ways, graphically, visually, tab tables, schedules, all sorts of things that give you that feedback on the complexity or completeness of your given set.
Yeah, I think that's great feedback, especially for engineers. I know a couple of old school engineers who will never automate anything. But then again, I know a couple of junior engineers that are working on like trying to make their job flow as seamless as possible. So also in the article from earlier this year, you mentioned that as daily work processes become more model driven and less time is spent looking at the drawings, the potential to miss critical details that are not modeled is introduced. So, some interesting things happen. I know SGH does a lot of, I think I'll do forensic engineering as well sometimes.
Quite a bit.
Do you worry that will lead to structural failures?
Not as much. It's not so much a structural failure. I think it's more of just a detail getting missed and maybe implemented incorrectly. So I think it's more so the statement I was trying to make with that is really that the drawings don't get looked at the way they used to. And so the drawing set, now that you have this kind of, it's almost like a hybrid model, right? You have these drawings and you have a model. Well, the model is simple and they can extract a lot of when I say they, contractors can extract a lot of information from that model, both for spatial coordination, material takeoffs, all sorts of things that they can do that are key pieces they need. What's often not in there are the little details that say, oh, you have to add this stiffener every so often. You have to add these kickers every so often. All those sorts of little pieces that we might, like I talked about before, we might not actually model all those pieces because it's very tedious and time consuming during design to do that level of detail and bring it to a true construction ready model. It's important to recognize that those details get conveyed into the final construction model. It gets pulled together, whether it's a steel model from a fabricator, and making sure where they do everything into it. They put all the nuts and bolts, welds, kickers, all those little ancillary pieces into it. From a forensic standpoint or from a fear of failure standpoint, I think it's more so of details getting missed and not implemented properly. They might see something in a model and not realize there's more to it than what's shown actually in the model. And that's, again, where communicating is key. That if you have something else in a model, either you can flag it, you can put some spatial elements in there to kind of say, hey, there's something else going on here. Make sure you look at this detail. So I think that's really the concern I have is as we move towards a BIM-based deliverable, where do we put those little things that have been typical details and other things that we just carried through all this time that people know how to do, but aren't necessarily shown in a model? And if we are moving towards a BIM deliverable, as an industry, we really need to be asking for more money because you're going to be putting more time and effort into that model to basically be taking it to a construction ready model at the end of design. And so I think that's really the challenge we have. Is it going to open up potential for misses? Yes, I think that's one of the concerns in general of trusting simply a model without some of the basic tools behind it. I also question, can you ever get to a fully model only deliverable? Because there's always notes, criteria, and I'll be honest, when lawyers get involved, you're going to have those CYA type things where you got to cover yourself and make sure that the information is conveyed to say, hey, this is the things you need to be responsible for. You need to make sure you keep it safe, make sure it's shored properly, all those other things that don't always get conveyed in the final model. And the notes, think of how much notes you add to a drawing set. Where do those get conveyed in a model? And is it just a series of clouds, a series of comments that are in a model space? Those are things I kind of wrestle with as far as how when we start getting to a model deliverable, what are we going to be tasked with making sure that we're communicating within that model, right? So again, it comes back to that communication. What's real, what's not, what's final, what's needs more information that's shown somewhere else. That's really the challenge, I think, when you have that deliverable as a model, or model is deliverable.
Yeah. And so in reference to like BIM modeling, there will probably always be a hybrid situation where you will have a plan set and then a BIM model. But I was curious, especially with how contractors and architects and engineers have worked together over the past 2 years, where all you had was digital communication. I feel like we've all gotten really good at it. I was curious if you see maybe, because I mean, we're talking about maybe a miss and we're taking it on the contractor side, but I feel like a lot of contractors have really driven BIM as being a deliverable that they offer in their premium package for a project. And I've seen it, you mentioned like the super large projects, the mega projects, but, I've even seen it for like medium to large size projects. So do you think, and for context, I also, because I worked in the industry and BIM wasn't a big topic to structural engineers like 4 years ago. Like it was not, no one was really talking about it except for those mega projects. And there's a very select few engineers that work on those. Do you see it being an issue on the contractor side? Do you see it just maybe a work in progress as projects become more automated and more modeled in the BIM space, that our communication within a digital area becomes better? What do you think?
I think what I foresee happening is sort of taking those models, and to your point, they got digitized. I haven't printed out a set of drawings in a long time. It's print PDF and send, right? I remember when I started my careers, you spend 4 hours printing out set after set after set, binding them, setting them, rolling them, and couriering them off to kind of meet a deadline to get the architect so they could bring a physical copy in. And even authorities having jurisdiction, like cities and towns and things, are starting to accept PDFs as their submittals because they want the record electronically, because it doesn't get, well, doesn't, not to say it doesn't get lost. It's less likely to get lost, or at least can be backed up. And so it can be backed up, shared, and everything else. So I think that electronic deliverable, we've moved from paper deliverable to electronic deliverable. It's just an electronic version of the paper still. It's still PDF, it's still a document set. And perhaps it's a hybrid that we end up issuing, is that you end up going to a model, and when you click on an element, it brings you up a view that shows you a 2D type view that has those notes and things embedded in it. And you have to check those things, and sort of maybe there's a sign-off process to say, I'm not just looking at just the 3D, I'm looking at those details you've got, sections, plans, anything else that have the notes incorporated with it. So we are kind of moving towards that fully digital process. Even site visits and processes within document management now with contractors, it is much more of a digital based process. And even like we talked about before, printing and redlining with an actual red pen, it's been years since I've done that. We've switched to electronic markups, especially in this now hybrid environment. The past 3 years, we've had to be virtual because I can't take a piece of paper, mark it up, and just sit next to you and talk it over. We have to figure out a way to do it on screen. So that's kind of forced our hand into a digital communication. And so I think it's just those confluences are coming together, and they're going to merge into a way of having a digital transfer, much like we kind of have right now. And even now, you send a model still. We share the model. It just comes with a caveat to say, hey, you can't really use it for X, Y, and Z because lawyers told me I can't give you all this because it's going to be, it's going to be a potential if there's something wrong in the model. Exactly. The drawings are still the ultimate thing that are stamped and deliverable. But I think we are heading to a time where that model is going to be something that you can somehow virtually stamp and tie it to the drawing set and have it be a package that's sent. I do think that's where we're heading, and I think contractors are pushing for that because it streamlines their flow as well. It's easy for them to parse things off, to show, to visualize. I think one of the biggest things I found with BIM is that cross-discipline information sharing. When I started, I had to learn how to read mechanical drawings and plumbing drawings and read them and be like, where do these ducts go? Where do these pipes run? How do they all match up? And now you can kind of turn it on in your model and visualize it. And you see the pipes, you see how they run, you see what they're connecting to. So younger staff, I think, have a better chance in this day and age of visualizing what's going on. And same with contractors. Contractors can bring engineers up or staff members, project managers in, and they don't need to be able to read drawings quite as they used to have to, because they can understand the visual 3D space from at least spatial coordination. So I think that visualization tool has become both a key and a crutch in the way we do design and the way that contractors rely on models, maybe somewhat more so than the drawings at this point. I feel like that's where things are heading. And so the design industry needs to make sure if that's where we're heading, and the contractors are driving it because they've got the big tickets, the big deep pockets, we're gonna have to follow suit and make sure that our models are working with the system that they're trying to implement.
Yeah, I think it's so interesting how the industry is going. I mean, I attended, it was just like a product demonstration in Houston a long time ago, and it was with BIM modeling. And it was exactly what you said. So it was like all of the MEP and electrical work and the plumbing, and it was through VR glasses. So it was a BIM model. They put on the VR glasses and you could see where all of those items were going to go on a construction site. Only thing is like, if you walked the line of the MEP, like you essentially would end up walking off the building because it didn't have like, the barriers. It didn't tell you when the end of, it didn't tell you where the end of the building was. But yeah, I think it's so interesting that is kind of how the industry is going. And I think it's really interesting that structural engineers are following suit because it's so important. Because I mean, also in Houston, I won't say which building it was. I've seen where, the modeling or, the electrical sheets, the mechanical sheets did not align necessarily with where all the structural beams were. And they essentially cut a hole straight in the middle of a beam. And, obviously a huge issue later on. So yeah, I think that's great that that's kind of where things are going. And I appreciate your perspective. I know a lot of engineers, I think, are dipping their toe in BIM modeling right now. Some of the bigger firms, of course, have already started. And then a couple of others are learning. Do you have any final advice maybe to younger engineers who are looking to learn BIM, because it is a value-added service for engineering companies to be very competitive? Or maybe for engineers looking to get started in BIM,
Just have to learn it. You have to learn, and the 800-pound gorilla out there is Autodesk Revit. It is the predominant one that is in most design shops. At least it's been sort of become the industry standard. I've been doing it since 2007. So when I first started with BIM, we took it on a project and had a major project we decided to undertake with it, and said, let's just cut our teeth and do this. It was an entire hospital campus that we did back then. And actually, it was interesting at the time because I actually was working with an architect that was using a different software platform. So we found ways to already do that interoperability between different platforms. It wasn't even Revit to Revit, it was Revit to a different software. And so I think we've taken that over the past 15 years, and BIM has become, Revit has become our standard practice. We've kind of ditched AutoCAD altogether because of the document management capabilities that BIM brings. It takes a lot of those, that we talked about before, efficiencies, mundane tasks, about making sure your section cuts number correctly, making sure your sheet numbers change. If you change a sheet number, the references are all changed. I remember going through paper copies with, okay, highlight every section mark on there and make sure it actually keys into the correct section. You don't have to worry about that anymore. That's been taken off the task list. And it was a mundane task that offered no engineering value, right? That's not engineers doing engineering. That's engineers doing mundane tasks. And so trying to take those mundane tasks away, that's where the modeling has really helped in quickly being able to cut sections, visualization, sharing information, communicating, taking screenshots, or jumping on a Zoom and spinning the model around and looking at things together. That's where I think leveraging BIM is absolutely critical to staying efficient and staying part of the game. Frankly, if you're not in BIM at this point, I wonder, where have you been for the past decade? Because it's been coming for 15 years plus. And so I think for that, if you're not on it now, you're behind the curve, and you're quickly maybe getting left behind if you're not following it at this point. So for young engineers that are learning it, take it, play with it, take it for a spin. There's a million different ways you can learn online. I know a lot of schools are offering Revit classes and BIM training classes, analytical classes. Just learn as much 3D modeling as you can, whether it's analytical, whether it's Revit or some other modeling tool, Tekla or others that are out there. The more 3D visualization you can do, the better. And as I said, this generation that's coming up has grown up with all this tech around them. Video games, I grew up with very vintage video games. Now you're seeing these video games that are completely immersive, right? They're yes, almost live action. And it's so the visualization of that, and that's, I think, where the industry is heading. You talked about VR and augmented reality and everything. The graphical capabilities of everything has improved so much. You're getting much more realistic renderings and views and integrations. And it's the ability to show those things and share those things with different disciplines. And that's the key, I think, that BIM brings, is it helps all disciplines communicate to put the entire building system together. It's not just the structural elements. That has to coordinate with the architectural elements, with all of the walls and everything else that goes into architecture. It has to coordinate with all mechanical systems, electrical systems, like you mentioned, beam penetrations. Making sure those things are in. And if you want to be super efficient with them, you have to have that coordination, communication early. And oftentimes it means bringing a contractor on board early, because the design team, as I said before, has limited budgets. We're only going to model to this stage. The contractor wants a higher stage. When you bring the contractor in, maybe during design, they start to develop those models and say, hey, let's start putting these things together so we can get that virtual build. I think as an industry, we're heading towards virtual building construction. Like, virtual buildings is where we're heading, and you're going to see designs before they truly get built. Maybe it's right before they get built, but you're going to have a true virtual rendering of that building, of all the components that go in, because it's going to be necessary to make sure you're minimizing the time spent in the field, right? The time is money. So I'm hoping as an industry, we spend a little bit more time up front to plan a building out. And then when you get in the ground, you can do it faster, because now you know exactly what you got to do, and you can parse it off to make those components work.
Yeah, like I said, the future, you've said it, it's the future of engineering is more automation and more digitalization. I keep seeing it. It's actually really interesting. I was reading an article, it was popped up on my LinkedIn, and it was how, what you said, the paper plans are going away. And I'm like, I am glad, because I did environmental engineering when I was in school. But it's also like, as we move into a digital space, for some it's going to be a learning curve, and for some it's going to be really quick. Like you mentioned it quite a few times, younger engineers these days are more digitally capable, just based on how their education and how they were brought up. So yeah, I think that's great final advice to, just maybe have everyone just open up Revit and kind of play around a bit, because it's definitely a new world for quite a few of us. But yeah, thank you so much for your time today. It was a great discussion. I know a lot of engineers are really interested in BIM modeling and automation, and moving the industry in that way to make it more effective during the design period and during the construction period as well. And yeah, look forward to your next Structures Mag article.
I guess, and if I could close with one more thing, just if anyone is interested in more digital design and what we're doing, Structural Engineering Institute has a digital design committee. I was chair of it for 7 years. Christopher Dane, one of the co-authors and a couple of the articles with me, is now the chair. Through that group, it's just a good group to have a good conversation about where we're heading in this digital world. We kind of share stories and publish a few articles like this. We talk about it at Structures Congress and a few other type of conferences throughout the year. But it's really a chance to kind of have people communicate. So if anyone's interested, please reach out to me or to Christopher Dane. And we can try to get you in touch with that. Maybe we can even add a link or something to this at some point to link it up and have people coordinate with it.
Yes, we will link it on our on the page so that they can check it out.
So learning more that way.
All right. Thank you so much, Mike.
Thank you, Kay. I really appreciate your time. Thank you.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or any questions you may have. To leave them, please visit structuralengineeringchannel.com. There you will find a summary of the key points discussed in today's episode, which is episode number 85, as well as links to any of the resources, websites, or books mentioned during this episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcasts. Until next time, we wish you the best in all your structural engineering endeavors.